Hey everyone, it's Bradley Bush with another calculus video for you. Today we are talking about finding derivatives of composite functions. So composite functions, just in case you forgot, would be like f of g of x or g of f of x. And we have one worked example here for you, and I think that this will be really helpful. Let's get started. So here's the question for you. Find the value of f of g prime evaluated at x equals 4. So if they give you f, for example, is cotangent of pi over 20 times u, and then they give you the g function, which is 5 times root x. We probably want to know what exactly is f of g before we can find its derivative. So if we find out what f of g is, we just have cotangent of pi over 20 times whatever g is, and g we know is 5 times root x. Now if we wanted to figure out what the derivative is, we've got to use the chain rule here. This is a perfect application of the chain rule. So f of g prime of x, that means we take the derivative of the outside. So f of g just means g is an input to f. F is the outside function, g is the inside function. So I take the derivative of f, leave g the same, and then multiply that by the derivative of g. So it's a straightforward application of the chain rule. And if we find out, if we do a little simplification here with when we compute f of g, we said f of g was the cotangent of pi 20th times 5 times root x. We can do some simplification here. This 5 can go on once, and the 5 goes into 24 times. So that 5 pi over 20 just becomes pi fourth. So in the end, our composite function that we want to take the derivative of is just cotangent of pi fourth times the square root of x. So cotangent of quantity, pi fourth times square root of x. Let's actually take the derivative. We first need to take the derivative of the outside, which is cotangent. And just as a reminder, the derivative of cotangent is negative cosecant squared. So we have negative cosecant squared. We leave the inside the same. G stays the same, so we just have pi fourth times root x. And now we're multiplying by the derivative of g, which is pi fourth times the square root of x. So, well, that isn't technically g. It's the inside, derivative of the inside. Because we kind of combined g with the stuff that was already inside the argument in cotangent. So it's now slightly different, but we're still taking the derivative of the inside. So one thing we want to do is we want to change the root, the square root symbol, to its exponent form. So instead of having root x, we will have x to the 1/2, and that helps us. So the derivative of pi fourth times x to the 1/2, we just use the power rule now, and we can pull the 1/4 out because it's a constant. So the 1/4 comes out, and the x to the 1/2, the 1/2 comes down in front, and we subtract 1 from the 1/2 in the exponent and get negative 1/2. The pi fourth and the 1/2 become pi eighths, and we have x to the negative 1/2. That negative tells us that the x needs to go down to the bottom, and we can put it back in its radical form. So we have negative cosecant squared of quantity pi fourth times root x. That all is just carried down from the very first step. And the derivative of the inside ends up being pi over 8 root x. Now we have found our f of g prime of x is negative cosecant squared of quantity pi 4 times root x, all multiplied by pi over 8 times root x. Now we just evaluate that at 4. So we plug in 4 everywhere there's an x. So the square root of 4 is 2. So this root 4 becomes 2 inside of the cosecant squared. And the root 4 in the denominator on the outside becomes 2 as well. The 2 and the 8 in the denominator become 16. And we can reduce this fraction. 2 pi over 4 just is the same thing as pi halves. So negative cosecant squared x of pi halves just reduces to negative 1. And then we have the negative 1 times the pi over 16, which gives us our final answer of negative pi over 16. And that's the answer. Hope this was helpful. If it was, please give me a like, subscribe to the channel, and have a great day.